Station, this is Houston. Are you ready for the event?
Houston, we are ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
Houston ACR, we have you loud and clear.
The Space Institute at Rice University engages in research, technology development, and education. With colleagues at Scottish Enterprise and the Guayaquil Space Society, we have brought together students from Houston, Scotland, and Ecuador who are excited to talk to the International Space Station and for the collaboration among our schools going forward. Now it is my great pleasure to introduce the Right Honourable Nicola Sturgeon, MSP, First Minister of Scotland, for some opening remarks.
I want to say hello to all of the young people who are taking part in this uplink. I'm very grateful to the Rice Space Institute, NASA and all of the other partners who've helped make it possible. Today you all have a chance to hear directly from the crew of Expedition 64 about the research they're carrying out and about what it's like for people from different countries to work together for the common good. It's a brilliant opportunity and I hope you find it inspiring. And I know you'll all want to get on with the questions straight away. So let's move on to the first one.
Hello, my name's Cameron Kelman. I'm age 15 and I'm a student at Bathgate Academy in Scotland. My question for NASA is, how do you mentally and physically prepare for a long-term space mission? Thank you.
Hey, that is an excellent question because it does take a lot of preparation to get ready for a space flight. On the mental side, I don't know. You just really have to be ready to go. You have to know that you're going to be gone for your friends and family for at least 6 months, usually longer than that because we go into quarantine ahead of time. So you just need to be ready, and everybody prepares for that differently. Physically, you've got to be in shape to be able to do spacewalks, to be able to take the loads of launching and landing. And so we actually work with athletic trainers before we leave Earth to make sure we're in the best physical shape we can be before we get up here.
Hello, my name is Anela Franco. I am 14 years old. It's a privilege to ask this question in representation of my school, Unidad Educativa Javier, in Guayaquil, Ecuador. Once you have looked at our planet from space, what do you think about humanity's effort to live a sustainable life? Thank you very much for this opportunity.
Thank you. That is a wonderful question, and we're really excited to be speaking to you as well. Our planet certainly is beautiful. We can see it. We have some windows here in an area called the cupola, and we're pretty busy during the workday, but when we get a chance, we like to look down. Often this is maybe at night after all of our duties are done, and we see the Earth is such a beautiful and peaceful place, but we're also very struck by how fragile it is. There's just a very thin atmosphere. The planet looks like it's this beautiful, bright planet, but it's alone. It's got really the dark cold of space surrounding it. And so I think it helps us think a lot more carefully about this is the only place that we've got. This is where humanity lives. And we do get a strong sense that we need to take very good care of it. We're interconnected, and it is a fragile oasis.
Hi, my name is Megan, and my question goes out to any and all astronauts. How does food preparation differ in outer space, and are there any extra measures you need to take in order to ensure proper nutrition?
Oh, that is a great question, Megan. Nutrition is important, and you are absolutely right. Nutrition is important on the ground, and it's very important in space, too, because what we eat can affect how healthy we can remain up here. While we're in space, we are constantly losing bone density, so we need a way to keep our bones strong. Some of that's through exercise. A lot of that's through nutrition. So how do we do it? Well, we've got teams of people on the ground that actually prepare all our food for us and send it up to the space station. So we depend on them to make sure that our food is nutritionally sound so we can eat it up here. Preparing food up here is pretty simple. We just heat it up and eat it.
Hi, my name is Leah Mowbray and I attend Latent Academy in Scotland. And my question is, after completing a space mission and returning home, how long does it take you to recover physically?
That's a really good question. We're thinking about this now because all of us are getting close to the end of our mission. It takes about 45 days to do our complete physical rehabilitation. Really, we start feeling better in about the first week or two, but we have to relearn how to do a lot of things. So when we get home, we can kind of walk, but it doesn't look very graceful. And we lose a lot of things like our proprioception, our sense of balance, even just our ability to support our weight. Since we're so used to floating, we have to kind of learn how to walk again. So this takes quite a bit of time, and it actually it takes a lot of effort at the gym. We do a lot of different kinds of rehabilitation exercises. We're feeling good after about 2 weeks, and we're really back to our normal Earth-based selves after 45 days.
Hello, my name is Leo. I attend Baylor College of Medicine Academy at James D. Ryan in Texas. My question is, could a disease ever evolve in space, and could it reach the Earth?
Shannon gave this to me because I'm the virologist. That is a really good question. So we go into quarantine, we go into isolation before we launch. And the way that most diseases transmit is between people or between animals to people. So since we're isolated up here during our entire space mission, we're probably not going to have a disease that we don't bring with us. So we screen all the astronauts before they launch to make sure that they're healthy. You can have something called latent virus reactivation, where a virus that we carry within ourselves starts to become more prominent since we're a little bit more immunosuppressed, and Shannon's saying like chicken pox. But it's very unlikely that any new viruses would evolve up here because we don't have any other people besides the few that are up here, and we don't have any animals. And that's really how viruses evolve on Earth, and that's how they transmit on Earth. So because we're separate, until we start having hundreds or thousands of people in space, we're not likely to have any new viruses evolve up here.
Hi, my name is Maider. I go to Ballroom Primary in P3B. My question is, how much packaging does your food need in space?
I am sorry, I did not catch that question. We don't always have good uplink sound. Is there any way you can repeat it?
Station, this is Houston ACR. The question was, how much packaging does your food need in space?
How much packaging does our food need in space? That is an excellent question, because actually that is something we are always complaining about. Our food has too much packaging, we think, and it creates a lot of trash that we have to deal with up here. So I think we would like it if we had less packaging. Right now, we have dehydrated food that comes up. It's in a plastic bag that we can inject the water into to make our meals. And that plastic bag is wrapped in something else. So if we could get down to at least one bag instead of two, that'd be better. And if we could do something that it would actually degrade as opposed to just plastic trash, yeah, maybe we need to figure out how to do composting up here. That would be even better.
Hi, my name is Elena Munoz, and I attend John Levin Academy in Guayaquil, Ecuador. My question is, because of lockdowns that paused transportation and industry severely during the pandemic, what changes have you noticed across the Equator?
That's a really good question. Because we circle the globe every 90 minutes, we can see all parts of the world. And when I launched, there was already the pandemic going on. And I'm a virologist, everybody's been hearing about this, but I was really thinking about it. We did have a very interesting study where we were taking photographs of cities at night, and we were trying to see if human movement in these cities was changed in the pandemic. And I think they have seen that there's differences in the cities before the pandemic versus now. Obviously, people are moving around a lot less. So we can't see too much at the individual person level. About the biggest thing we can see is things like cars and buildings, but we can certainly see lights. And we have noticed, if you look at things like commercial air travel, very early on, the number of flights going across, we can see the trails that the airplanes leave. That's reduced, and then some of the lights in the city are reduced because of the pandemic.
Hi, my name is Lorna Nails, and I'm an 8th grade student at Baylor College of Medicine Biotech Academy at Rusk. And my question is, what was the most surprising aspect of taking a spacewalk?
That's a good question. We did 5 spacewalks on this mission. It was a lot. Each spacewalk takes a lot of effort by the whole team. So it's not just the people doing the spacewalk. This is everybody on the ground involved, and then there's hundreds of people on the ground that help out and on board, of course, also. The effort involved is pretty significant. We plan for it for weeks and months when we're training, and the ground teams plan for years. Some of the harder things to overcome are just being in the vacuum of space. We don't train, we train underwater, but we really don't train in vacuum. And the other really hard thing is that it's night. We go day-night cycles, and so all of our training on the ground we do during the day, but we have to get used to doing a lot of work at night where we have very little visibility. One of the cool things is we do get to see the planet through just our visor. So we're always paying attention and being careful, but we do get to take a few moments to look at the planet and see how beautiful it is.
Hi, my name's Robin and I attend Eastbank Academy in Glasgow. My question is, before your first trip to the International Space Station, you would have studied space in great depth. Now that you're experiencing it firsthand, is it what you imagined it to be? And if so, does it still amaze you?
Yeah, that's a good question. We do spend a lot of time studying about space, but it's really hard to adequately capture what it's like to be up here. You can kind of imagine what it's like to float all the time, but till you're doing it 24 hours a day, it doesn't really meet your expectations. So up here, I would say, one, it's a lot more interesting, a lot more fun to float all the time, but it's a lot more challenging than you might think because you're always having to find ways to stabilize yourself, and you really, really have to keep up with all your stuff because if you don't put it someplace very carefully, it is going to float away and you're going to spend 2 days looking for it. So yes, it's kind of like what we expect, but not entirely, and it's a great place to be.
I am Valeria Serra. I'm 15 years old. It is an honor to contact you from the UE Javier in Guayaquil, Ecuador. The question we would like to ask is the following. How important is it to get schools involved in space education? And how can our school help promote this educational approach? Thank you very much. We look forward to your response.
Thank you. That is a wonderful question. We think it's incredibly important. Shannon and I are doing this event with all of you because we think this is so incredibly important to get young people involved in space and space science. There's a lot of things that we do up here that actually students can participate. We do things like CubeSats. We actually launch satellites from the International Space Station, and university students can work on these. We have projects that high school students can work on. So there's a great project. It's called Hunch that actually some local area high schools participate in. I was just using one of their items today. They design things that are going to be useful to astronauts and they fly them up onto the space station. So it's I think one of the most important things that Space Station can do is serve as an outreach tool to young people. And certainly if you're interested in space science, you can go to the nasa.gov website, and there are all kinds of projects that your school can do, that you can do with your friends, and that you can get people in other schools interested in. At any grade level, I would definitely recommend checking it out. And if you get a chance, fly us an experiment up to Space Station. We would love to work on it.
Hi, I'm Vian. I'm 6 years old. I'm in elementary school, and I want to ask you, does your hair get tangled in space?
Does our hair get tangled in space? That is an excellent question. Maybe not as much on the ground. I don't know. We don't have the wind up here, so that's not going to tangle our hair. But look at Kate's hair. It just floats around. I keep mine in a ponytail so it doesn't get stuck on Velcro and get into things. But your hair can be a lot of fun up here for sure.
My name is Grace and I attend Holy Family Primary near Glasgow, Scotland.
My question is, do you have to keep a record of the space debris in orbit, and can it be dangerous to the space station?
That's a really good question. It's actually a really important one. We do have issues with space debris. So when we launch things, for example, rocket fairings can sometimes fall back to Earth, but sometimes they stay in orbit. When satellites are at the end of their service life, they can stay in orbit. Sometimes they collide and they make a lot of space debris. So this is a concern. There's a lot of people that monitor space debris on the ground, and if we have an object that's big enough, we'll make sure that the space station avoids that so we don't have a possible collision. But it's hard to track all of these objects. And so this is something, if you guys are interested in what the future of space is, learning about space debris and how to avoid space debris, how to plan for it, how to make sure that we build our satellites in a sustainable and renewable fashion so that we plan for those satellites to come back to the Earth, to burn up, and not to litter the atmosphere and to litter the orbit with space debris. So there's a whole field out there. We have a lot of people working on it, but we definitely can use some more smart people thinking about this.
Greetings, I'm Santiago Kuhn from Unidad Educativa Javier in Guayaquil, Ecuador. I'm 12 years old. I would like to ask the following question to the astronauts. How can experiments such as the one conducted with the seeds will contribute with our goal of living in space? It is a pleasure to contact you.
Houston ACR, can you help?
Station, this is Houston ACR. The question is, how can experiments such as the one conducted with the seeds contribute to our goal of living in space?
Yes, seeds. Very good question. It is so important for us to learn how to grow plants in space, because if we're going to take long trips, say, to Mars, we're not going to want to eat packaged food the whole time. We're going to need a way to grow our own food. And so we've actually done a lot of experiments up here. We've got some plants going right now. So we're looking at how do you adequately water the plants? How do you get plants the nutrition they need so they can grow properly and produce food for us? So it is amazingly important, and it's just something that we're only taking the baby steps at now, but we really need to figure it out so we can get more places in our solar system with people.
Hi, my name is Sasha Mackay and I attend Preston Academy in Scotland. My question is, do you have a time zone? Does it affect your everyday lifestyle or your sleeping pattern? Thank you.
Station, this
and
is
Houston ACR. Sorry.
Station, this is Houston ACR. The question is, what is your time zone and how does it affect your sleeping pattern and daily routine?
Thank you. Yes, we are on Greenwich Mean Time, so we're about London time. We picked that time early on in the space station days. We've got control centers all over the world, and so we had to pick a time artificially to be on. And this is about halfway in between Houston and Moscow times, and so it's staffed 24/7 in all these different control centers. So we kind of stay on this sort of European London time zone, and we shift when we get up here, and we just stay on that unless we have a visiting vehicle coming. If we have something docking to the space station, we might need to get up in the middle of the night because of the way it launches and orbital phasing. We have 16 sunrises and sunsets a day. Mostly we're actually inside, though, and we have artificial light. This can affect your circadian rhythm negatively. One of the new things we've done recently is put lights up that have different wavelengths, and so we can adjust it to have less blue light in the evening when we're trying to sleep and more blue light in the morning, and that helps some of our circadian rhythm adapt. But it is one of the big challenges that we have in space.
Hi, my name is Caitlin Davis, and I'm a student at Michael E. DeBakey High School for Health Professions. And my question is, how do astronauts from multiple countries collaborate in spaceflight for scientific advancement?
Yeah, that is an excellent question. How do we collaborate up here? Well, this is the International Space Station, so one of the ways that we do it is by having international astronauts. Right now, our crew is composed of 4 American astronauts, 1 Japanese astronaut, and 2 Russian astronauts, and we all work together to accomplish the science up here. So, for example, right now, one of the partnerships that we have for the International Space Station is the European Space Agency. Well, there is no European astronaut up here, so we work with the European experiments to make sure that their science is accomplished. If, say, in the future we don't have a Japanese astronaut, well, we will all, whoever else is up here, will do the Japanese experiments. So we work together to accomplish great things.
Well, that was brilliant. My name is David Alexander. I'm the director of the Space Institute at Rice University in Houston, Texas. And I'd like to thank NASA, Dr. Rubins, Colonel Hopkins, and of course all of our young participants who made today such a special event. Thank you all.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants. Station, we are now resuming operational audio communications.